Hello and welcome to TESLAMAN's very first video. And in this video, we're going to try and understand charges. Now, you might have seen that whenever we take a glass rod and rub it, let's say with a silk cloth, and if the glass rod is brought near pieces of paper, they begin kind of rising up or sticking to the rod, right? But have you ever wondered why exactly this happens? Well, when I was in my lower classes and when I saw this experiment performed for the very first time, I was quite confused. When I asked some seniors of mine about the same experiment, they told it was because of static electricity. And apart from being a big word, it didn't help me realize the idea, or it didn't mean much to me. Later on, I went on to realize that it was a deeper idea, much more meaningful and tangible than what the big word have people thrown at me for so long. So here I am sharing what I've learned over the years, and without further ado, let's go ahead. You might be familiar with mass. Alright, you see, the word mass has been in our textbooks forever. You have seen weights, alright, let's say 1 kg weight. You've seen these weights around in the market also. You know that most of the things around us have mass. For example, let's take a stone or let's take a ball. All these things have got mass, right? You might also be knowing that all mass attracts each other from the famous Newton's law of gravitation. So this means that mass comes only in one type, right? Now, there is another property of matter, just like mass, and that is called as charge. In fact, mass is a property of matter, alright, property 1, let's say, and charge, just like mass, is property 2. Alright, so in fact in archaic English, charge means to carry, as if matter is carrying charge along with it. So listen to me now. Matter carries two things along with it. The first thing is called mass and the next thing is called charge. Okay, now this charge, unlike mass, which is only attractive, see, mass is only attractive because Newton's law of gravitation has helped us prove that mass is only attractive. But charge comes again in two types. One is called positive and the other is called negative. It also happens that like charges, that is positive charge, two positive charges or two negative charges repel each other, and the unlike charges, that is one positive charge and one negative charge, attract each other. Now, to understand charges in a much more systematic way, we have to go into the atomic level and see what's happening at an atomic scale. Now, what I want you to know is that there is a nucleus at the center of an atom. So here's an atom. Okay, here's an atom, a very weird picture of an atom, only with the one shell. You've got an electron here, you've got a nucleus here. So there is, now what I wanted to know for the present is that there is a nucleus at the center of an atom. So this is called the nucleus. There's nucleus at the center. This is very weird C. Yeah. And electrons that kind of revolve around it, though they actually do not revolve in perfect circles. It is these electrons right here, that make bodies gain or lose charge. The electrons are negatively charged, while the protons inside of the nucleus are positively charged. Now, by the way, nucleus contains two main entities, protons as well as neutrons. Protons are positively charged and neutrons are neutral. Okay, and since positive and negative charges attract each other, electrons and protons are held together in the atomic space. The electrons kind of revolve around the nucleus in some sense, in some very weird sense. Okay, so it is the protons and the electrons that are majorly responsible for the charge phenomenon around us. They are the ones that contain charge, and they are the ones which are responsible for bodies gaining or losing charge. Okay, now since protons are well held inside the nucleus, by a force called as the strong nuclear force, about which you'll learn in very much detail later. It is only the electrons that can be exchanged to create excess charge or lose the excess charge. Now what I mean to say is that nucleus are inside the nucleus you got positive protons and neutral neutrons. Now these protons and neutrons are well held together by a force called as the strong nuclear force. Let me write that down: strong nuclear force. This force is even more stronger than much more stronger than a gravitational force. In fact, this is the strongest force in the entire universe. So the protons and neutrons are held together in the nucleus by this force called as a strong nuclear force. So the protons are well secured in the nucleus, and from this it's very obvious that bodies around us can gain or lose charge only through electrons from their atoms, right? So this means that bodies can gain or lose charge only in a certain minimum denomination, which is a charge of an electron. So because only electrons can be exchanged in order for charge to be created, charge to be transferred from two bodies, from one body to the other to another, this means that bodies can gain or lose charge only in certain minimum denominations, okay, which is a charge on an electron. So this property is called quantization of charge. In short, quantization of charge basically states that charge cannot be exchanged in a continuous manner. It can only be exchanged in a certain discrete manner, okay. That is see, let's take the charge on electron. For example, let's take the charge on an electron to be E, okay. Now let's take the total charge on a body to be Q. Q will be equal to N into E, where N is a number of electrons. So charge can only be an integral multiple of the charge on an electron, okay. This is what quantization of charge basically states. Quantization of charge states that charge can be exchanged only in a certain minimum denomination and not in a continuous manner, okay. So let's go ahead and understand charge further. Now let's think about an idea. Let us imagine that there is an atom and somehow we manage to isolate a proton from its nucleus. Let's say this is a proton that we have taken out of the nucleus, okay. This is a nucleus, by the way. So yeah, if we consider the proton as our system, which is the only part of the universe we care about for the present, can the proton actually lose its charge somehow? Think about it, no? Can the proton lose its charge somehow? By some means? No, it cannot. Charge is an intrinsic property of the proton or the electron, and it can never be lost from them. Thus, charge can neither be created nor be destroyed. This principle is called as the law of conservation of charge and is completely valid even in very high energy scenarios. So law of conservation of charge states that charge can neither be created nor be destroyed. In fact, charge can only be transferred from one body to another by the means of transfer of electrons. But it doesn't imply that the total number of charged particles are conserved. Let me give you a better example. So let's say you got a box, okay. Let's say we have a proton here. Let's say we have 4 to 5 protons. The total charge here is plus 5 because proton has a positive charge, and we are assuming that each proton has a positive 1 charge. Let's say, in fact it happens that a proton might split up into a positron, which is a positive version of an electron, and a neutron, okay. If you see, a single proton has now become 2. So now what is the number of particles in this entire box? It is 2 plus 4, which is 6. So the number of particles was previously 5 and now and now it became how many? 6, okay. So additionally 1 particle came. So what happened now? The number of particles have actually changed, but if you count the charge, it is plus 1 plus 4, which is plus 5, which remained intact. Okay, so the amount of charge remains intact, but the number of charged particles might not. So this process where a proton actually splits up into a positron, which is again a positive version of an electron, about which you'll learn in very much detail in coming chapters, and a neutron, is called as a beta plus nuclear decay. Okay, nuclear decay because a proton is a part of the nucleus. Okay, the net charge again, however, remains conserved, and this idea is to be kept in mind as long as you keep learning this chapter. So you were introduced to the idea of charge and the two basic laws of charge which charge seem to obey, that is the quantization of charge and the conservation of charge. Thus we have sowed the seeds to our foundations of the study of electromagnetism, and your support goes a long way to improve my content. So I request you to subscribe to this channel and also tell me about how you feel after you've watched the video. Okay, thanks for watching the video. Hope to meet you soon. Take care. And by the way, this is my first video, so there might be many errors creeping in, but I promise that I'll surely learn from my experience shooting this video. And with all the inputs received from you, I believe it's going to be a great time running this channel on YouTube. Thank you guys. Thank you so much, and take care once again.